Let's move into the next topic, and it is the concept of radiation pressure or radiation force. It's a very interesting concept. So let's understand fundamentally what is a radiation pressure or radiation force. Now, the force or pressure experienced by any surface exposed to radiation is called radiation pressure or force, as the case may be. I repeat again. Radiation force means the force experienced by a surface exposed to radiation. And similarly, radiation pressure is the pressure experienced by surface exposed to radiation. So we can say the radiation pressure will be equal to radiation force divided by area. That's the simple relationship between pressure and force. Now, how to make calculation for radiation force or pressure? Now here we make use of two concepts. The first concept comes from Newton's second law of motion, that says the quantitative definition of force, and according to it, force is equal to rate of change of momentum. So mathematically we can write F is equal to dP by dt, where P is referring to momentum and F is referring to force. The second concept that we invoke in calculation of radiation pressure or radiation force is the particle nature of photon. So we know that the energy of photon is equal to E is equal to hf. Another relation we invoke is E is equal to Pc, that is energy and momentum of photon are related by these equations, that is E is equal to Pc, c is speed of light. So while making calculation for radiation pressure or force, so we make use of basically three relations. That is, first is the definition of force itself, that is Newton's second law of motion. Force is equal to rate of change of momentum, that is F is equal to dP by dt. The second relation we make use of is energy of photon, that is E is equal to hf. And the third relation is the relation between energy and momentum of a photon, that is E is equal to Pc. Now, to understand how the calculations are done, so let's take up a very simple example where we have a surface and this surface is exposed to radiation. Let's say the intensity of radiation is I. Now let's follow step by step, and we are considering the case that the surface is perfectly reflecting. Now we have to make calculation for radiation force experienced by it, and subsequently we will be calculating the radiation pressure. Now let's make calculation for energy received by surface per second. Now the energy received by surface per second will be intensity multiplied by area of the surface exposed to the radiation. Now here it is given that radiation is falling on the surface normally. So capital E, that is energy received by surface per second, will be intensity of the radiation multiplied by area. Now if I say number of photons falling on the surface per second, so we know the energy of one photon. So just by making use of a unitary method, so N, that is number of photons falling per second, will be energy received by surface per second divided by energy of one photon.